This is Chapter 9, Lesson 1, Adding and Subtracting Polynomials. You should be on page 554. We're going to spend the first couple minutes of this video talking about some important vocabulary you're going to need to know to get off to a good start in this chapter. Let's start with the term monomial. A monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. Now, there's a lot of things I just said there. Let's think about monomial. Mono means one. So this is indicating one term. We'll talk about that more in a little bit, but monomial means one term. Now, read this carefully. A monomial is a number, a variable, or the product. Now, what does the word product mean? Think about that. Product is multiplication. So if I take a number, a variable, and I multiply number and variables together with whole number exponents, that's still considered a monomial. And I underline whole number exponents. I can't have negative exponents. Whole numbers are positive. I can't have fractional exponents. To be a monomial, the exponent has to be a positive whole amount. Here are some examples of monomials. Let's make sure we understand why each of these meet the definition. Well, 10 is definitely a monomial. It's just a number, which meets the criteria here. Okay. 3x is a monomial. It's a number and a variable multiplied. That's a monomial. 1/2 a times b to the second power is a monomial. It's a number, half, multiplied with variables, and those variables have whole number exponents. This is definitely a monomial. Negative 8.5 m to the 5th. That's a monomial. I'm taking the number, I got a number, negative 8.5, and I'm multiplying it, product, I'm multiplying it with a variable that has a whole number exponent. Every one of these are monomials. Now, the degree of a monomial is the sum, let me underline that word, it's the addition of the exponents of the variables in the monomial. The degree of a non-zero constant term is 0. So let's review that. A constant is just a plain number on its own. So this is saying plain numbers on their own have a degree of 0. So let's read this again. The degree of a monomial is the addition of the exponents of the variables in the monomial, and the degree of a non-zero constant term is 0. The number 0 doesn't have a degree. So you might be like, well, what? I'm not quite getting it, okay? Let's look at the degrees of each of these monomials. I think after we look at it, it will make more sense. Now, the number 10 is a monomial and it's 0 degree because of what I'm underlining right here. The degree of a constant is 0. 10 is just a constant. It's a number. So its degree is 0. Okay? 3x. This monomial has a degree of 1. Here's why. The number 3 has a degree of 0, and x would be considered to the first power. Well, 0 and 1 add up to 1. This is a degree of 1. Let's go to this monomial, 1/2 ab squared. The number half has a degree of 0. The variable a would be first power. It has a degree of 1. And the variable b is to the second power. It has a degree of 2. If I add 0, 1, and 2 together, I get third degree. This is a third degree monomial. And on the bottom, negative 8.5 m to the 5th power. This is a 5th degree monomial. Here's why. The number negative 1.8 has 0 degree, but m is 5th degree. 0 and 5 add up to 5th degree. That's how you find the degree of your monomial. Now, let's look to the right. Here are examples of things that are not monomials, and I want to make clear why they're not, okay? 5 plus x is not a monomial. Here's why. Monomials are numbers and variables you multiply together. This is added. Sums are not monomials, only products. 2 over n is not a monomial. Think about this. When you divide by n, isn't this the same as 2 times n to the negative first power? Think about that for a minute. If I have n to the negative first power, it means move n to the denominator, like you see here. Well, remember, we have to have whole number exponents. N has a negative exponent. That's why it's in the denominator. That's not a monomial then. Okay? So it can't have a variable in the denominator because that means it would have had a negative exponent. 4 to the a power. That's not a monomial because a is not a whole amount. It's not a whole number. I got to have whole number exponents. So this is not a monomial. And x to the negative first power, of course, can't be for the same reason as I had up here. We can't have negative exponents. So hopefully what I just went through here is clear on what a monomial is. We have to know that, and we got to know a degree of a monomial before we can move on. Let's talk about a polynomial next. A polynomial is a monomial or a sum of monomials. So polynomials would be a monomial on its own, or if I add monomials together. Now, if I do that, each is called a term of the polynomial. Okay? Like, for example, this is not a monomial, but this would be a polynomial. It's the monomial 5 plus the monomial x added together. This thing would be called a polynomial. Poly means plural. It means like more than one. Polynomial means more than one monomial, basically. Okay? The degree of a polynomial is the greatest degree of its terms. So what you do with a polynomial is you look at each term. Like this would have a degree 0, and this would have a degree here of 1, and 1 is the biggest degree of any of its terms, so this would be a first degree polynomial, what I have up here. When a polynomial is written so that the exponents of the variables decrease from left to right, the coefficient of the first term is called the leading coefficient. So, this is important. If I order my degrees from greatest to least, the number in front of that first term is called the lead coefficient. Okay, so when you look at the statement here, can you see how this monomial is third degree, this one is second degree, this monomial is first degree, and this is 0 degree? This polynomial is written in order of degree from greatest to least. The number, let me highlight it, the number in front of that first term is called the lead coefficient. So this has a lead coefficient of 2. Do you notice the highest degree in any of these terms is 3? So the degree of this polynomial would be third degree. And there's only one constant in this polynomial, it's 12. That's the only value that doesn't have a variable with it. Okay? Let's talk about rewriting a polynomial. Write this polynomial so that the exponents decrease from left to right. Identify the degree and the leading coefficient of the polynomial. So let's look at this for a minute. This term has a degree of 1 because 15 has no degree and x has first degree. That combines for 1 degree. This has a degree of 3 because it's third power, and a number has a degree of 0. So if I write this in descending order of degree, the negative x to the third power should be in front, which I have there. The plus 15x should come second, which is C, and the plus 3 should be at the end because that's 0 degree. So right now, when I write this way, the greatest degree is 3. Okay, so this is a third degree polynomial. And can you see how the number in front of my first term is -1, the lead coefficient's -1? You're definitely going to be asked that in your homework, to write polynomials in order of degree from greatest to least and to name the lead coefficient. Binomials and trinomials. A polynomial that has two terms has a special name. It's called a binomial. Now think about it. Like bicycle, bi. Bi means two. Two terms. A polynomial with three terms is called a trinomial. Tri means three. Now, if you get past three terms, there's no special name. Like, we don't call a four-term polynomial a quadnomial. There's no such thing. We would just call it a four-term polynomial. All right? Let's identify and classify polynomials. You'll be asked this in your homework. Tell whether the expression is a polynomial. If it is, find its degree and classify it by its number of terms. Otherwise, tell why it's not. So let's go through this table. The number 9 is a monomial. If it's a monomial, it is a polynomial. See, so they put yes. This would be no degrees. Numbers have 0 degrees. This would be a 0-degree monomial. Let's look here. Is this a polynomial? Well, that's a monomial, that's a monomial, and that's a monomial. Everything there is a monomial. So yes, it is. It is a polynomial. It's 3 monomials added or subtracted together. Can you see how this is second degree in front, first degree in the middle, and 0 degree at the end? This would be a second degree trinomial. I got 1, 2, 3 terms. C, this is not a polynomial because I don't have a positive whole exponent here. I have a variable exponent. So this is not even a polynomial. D, D's not a polynomial either. I have a negative exponent. E is a polynomial. It's one monomial here and one monomial here, so yes, it's a polynomial. Now, do you notice it has 2 terms, so it's called a binomial, and let's check out my degrees. My first monomial has 0, 1, and 3. This has 4 degrees, and this monomial has 0, 4, and 1. This one has 5 degrees, so the highest degree is 5. This is a 5th degree binomial. Let's talk about adding polynomials. To add polynomials, add the like terms. Now remember, like terms have to have the same variable and the same power. You can use a vertical or horizontal format. Based on past results, I would recommend a vertical format. When my students in the past have tried horizontal, I'm not saying you can't do it that way, I just see more mistakes with horizontal. I would recommend vertical, but it's your call. Okay? Let's look at this. Like, look at A. We have third degree, second degree, first degree, and then we're adding that with this, which is second degree, third degree, and 0 degree. So look at what they do. They take this statement and they write it here. They put third degree, second degree, first degree. Now underneath, you notice how, let me take a highlighter, this is second degree, so it's put in the second degree column. And this one here is third degree, so they put that in the third degree column. And here we have 0 degrees, so I'm putting that in the 0 degree column. Well, it's pretty hard to screw this up now. I'm adding 2x cubed plus 1x cubed is 3x cubed. Negative 5x squared plus 2x squared is negative 3x squared. 1x plus 0 is 1x. And 0 plus negative 1 is negative 1. There is the correct addition of these 2 trinomials. Now, in part B, if you want to do it using the horizontal method, I'm okay with that. I just see that there's more mistakes. I'm going to quickly set this up with the vertical method. I have 3x squared plus 1x minus 6. So here are my second degrees, here are my first, and here are my zeros. Now over here, x squared is second degree, 4x is first degree, and 10 is 0 degree. All I got to do is add these up. 3x squared plus 1x squared is 4x squared. 1x plus 4x is 5x, and negative 6 plus 10 is 4. There is the correct response to this. Let's go ahead and do these practice problems. Let's try. Write this so that the exponents decrease from left to right. Identify the degree and leading coefficient of the polynomial. Pause the video and you try. Okay, we're back. This is first degree, the middle term is second degree, and the last term is 0 degree. So I should write negative 2y squared plus 5y plus 9. The degree is second degree, and the leading coefficient is negative 2. So it's second degree because that's the highest degree, and the lead coefficient, you can see here, is negative 2. Let's go to question 2. Tell whether this is a polynomial. If it is, find its degree and classify it by the number of terms. Otherwise, tell me why it's not. Pause the video and try that. Okay, we're back. This is definitely a polynomial for the following reason. Y cubed is a monomial, negative 4y is a monomial, and so is 3. Okay? Its degree, this is third degree here, first degree here, and 0 degree here. It's third degree, so we have a third degree, and then how many terms do we have? I had 1, 2, 3. This is a third degree trinomial for number 2. Number 3, let's find the sum, okay? Let me put these vertically. I have 5x cubed, that's third degree. 4x minus 2x is positive 2x, so I'm going to leave a space. So here are my third degrees in the pink column. In the green column, I have second degree. In the yellow, I have first degree. And in the blue, I have 0 degree. How's that? So now, underneath, 4x squared belongs in the green column. That's second degree. 3x cubed belongs in the first column. That's third degree. And the minus 6 belongs in the 0 degree. Okay, let me add them up. 5x cubed plus 3x cubed is 8x cubed. 0 plus 4x squared is 4x squared. 2x plus nothing is 2x, and I have minus 6. There's the correct addition. Let's talk about subtracting polynomials. To subtract a polynomial, add the opposite. You've heard this before. Subtracting is the same as adding the opposite. To find the opposite of a polynomial, just quickly multiply each of the terms by negative 1. So you can see this here in part A. Look at what they do. 4n squared plus 5. N squared second degree, 5 is 0. So here's my second degrees, here's my first degrees, here's my 0 degrees. You notice how they put the 4n in the second degree column, they put nothing in the first degree column, and they have 5 in the 0 degree column. Now, underneath it, we're subtracting negative 2n squared, that's second degree, plus 2n minus 4. Now, it says here, to subtract, add the opposite. And to change it to the opposite, multiply each of these by negative 1. So look at what they do. They take, instead of subtracting, they're going to add. Look at all these signs. They just change the signs. They change negative 2n squared to positive, positive 2n to negative, and negative 4 to positive 4. All we got to do is add these up now. 4n squared plus 2n squared, 6n squared. 0 plus negative 2n is negative 2n, and 5 plus 4 is 9. There is the correct answer to that. Okay? Let's quickly do one more. Let's do this one in a vertical format also. I have 4x squared minus 3x plus 5, and I'm going to subtract 3x squared minus x minus 8. Now remember, when you subtract, we can add the opposite of these. Let me quickly change these over to their opposites. So I'm adding the opposite. So the positive 3x turns negative, the negative x turns positive, and the negative 8 turns positive. Okay, let me start adding. 4x squared plus negative 3x squared is 1x squared. Negative 3x plus 1x is negative 2x. And 5 plus 8 is positive 13. And there I just got that. Okay? You will also have word problems to do, and then I'm going to wrap up the video here. Solve a multi-step problem. During Major League Baseball, teams are divided into two leagues. During the period 1995 to 2001, the attendance N&A, that's at National American League games, could be modeled by the following, where T is the number of years since 1995. About how many people attended Major League games? Well, to know how many attended, I have to add both leagues together. So look at what they're doing. They're adding both leagues. They're adding these numbers together. They did this in a horizontal format. Okay? So remember, if we are adding this plus the opposite is the same as subtracting. They're adding these together here, and they're adding these together here to get this statement. Okay, so we added N and A to get that statement. Now from here, the year 2001 is 6 years after 1995. So you notice, once they got this expression, they took 6 and they plugged 6 in for T here and here. So you can see that they're plugging in 6. And when you do that, you're finding out that in millions, because this, remember, is in thousands, we had 72,100,000 people attending these games. I'm going to pause the video here. If you have questions, make sure you ask in class.